evaluate if possible. So we're going to start out by eliminating any power of lower degree. So in this first example here, we can eliminate all the zero power terms, which will leave us with the limit as n tends to infinity. In the numerator, we have 4n times negative 3n. In the denominator, we have 6n times n. If we simplify the rational expression, the quotient here, we're going to get negative 12n squared in the numerator and 6n squared in the denominator. The n squared factors cancel, and we're left with the limit as n tends to infinity of, so negative 12 over 6 is negative 2. So the limit of a constant is the constant, so that means that the limit here is negative 2. In B, we start the same way, eliminating any zero order terms, leaving us with the limit as n is approaching infinity. In the numerator, we have 2n cubed. In the denominator, we have negative 5n cubed. If we evaluate those powers or simplify them, we're going to get, in the numerator, 8n cubed. In the denominator, negative 125n cubed. The n cubed factors cancel out like that. And then we're left with the limit as n tends to infinity of 8 over negative 125. So again, we have a constant here, which means that the limit is the constant. Like that. In C, same procedure. What we need to notice here is that we have n approaching negative infinity. So again, we're going to cancel the lower degree terms. So that one, and that one. And so the negative 4n in the numerator can be cancelled because 9n squared is going to basically overtake the numerator in terms of magnitude, and the negative 4n is not going to have any significance. But in the denominator, we need to keep the 6n because we're dividing essentially by negative infinity here. So in the numerator, we're going to have now, once we eliminate those terms. So what I'm going to do here is this negative infinity, I'm going to treat it as negative 1 times infinity. So in the next step, I'm actually going to substitute in negative 1. Okay. So we can write this as follows. We can say the limit as n tends to infinity now, because we're substituting in the negative 1, right? In the numerator, we have it's going to be square root of 9n squared. In the denominator, we're going to have negative 6n. The negative here comes from the fact that I've multiplied numerator and denominator by negative 1. In the numerator, the n is squared, which means that when n is negative 1, it becomes positive, right? So the entire numerator will always be positive because n is squared, while the denominator is going to be negative because 6 times n, when n is negative, the whole denominator becomes negative. All right? So 9n squared is perfect square, so we can take the square root of that. So we're going to get the limit as n tends to infinity. In the numerator, we have 3n. In the denominator, we have negative 6n. And the two n's will cancel against each other. And then we're left with the limit as n tends to positive infinity of 3 over negative 6. So it's going to be negative 1 over 2. The limit of our constants is the constant, so this limit is negative half.